Hi girls. I know that you guys are used to dealing with these videos at home on your own computers and at your own pace, so today is a bit of an experiment to see how it's going to work with the whole class while I'm not there. Maybe someone who's sitting close to the smartboard can be responsible to pause the video when it's necessary. There are a couple of times when I suggest you just stop it and copy what's on the screen. As we move from example to example, I will try and pause long enough so that at least you can copy down the examples. I have them all set up on the screens already. And if necessary, someone who's sitting close to the smartboard, just get up and tap the pause button for a little bit while the girls finish copying. I'm still in section 7.6, and today we're going to talk about solving equations with radicals in them. Last week we solved equations that had fractional exponents, so you raised each side to the reciprocal power, and today you're actually going to see the radicals in the equations. And there are two types of equations. One has one radical and the other type of equation will have two radicals. So right here I suggest maybe you pause the video and you want to copy down these four general steps that I have, and I'm going to go through each of them, in other words repeat these steps as we work through each of the examples. Before we move to the first example, I will go over the vocabulary that's at the bottom in step number 4. Alright, so why don't you stop the video for a minute or two while everyone gets these steps in their notes. Before we start the first example, take a look down here in step 4. I asked or suggest that you check for extraneous roots. The word extraneous, it's easy to remember right here. Extra. And by extra, we're really talking about solutions that are not going to work. The word roots means solutions. So when you check for extraneous solutions, you're going to check the answers that you get when you solve to find out if they really work. There are some types of problems that you create solutions that when you put them back in, you will find that they really do not work and you have to reject them. So with these types of problems, it should be a habit that you check your answers. When you check your answers, you want to make sure you do it in the original problem. So right here you'll see that I have the word original written in red. It's important that you remember to use the problem as it was given to you, not after you started moving the terms around. For every one of these problems, I'm going to check to see if we have generated any extraneous solutions. Sometimes you reject everything that you have, sometimes you reject one of the answers, and sometimes everything that you find is going to work and you're going to keep all of them. Alright, I'm going to change the page and we're just going to start to go through the examples here. So here is the first example. 2 times the square root of x minus 3 minus 10 equals 0. The first step in the process is to isolate that radical. So in this case, the 10 has to move to the other side, the negative 10 has to move over, and so does the 2. So I'm going to do that in 2 steps. Of course, you can do it in 1 step. So first you move the 10 over, then the 2, and we're here. So you've isolated your radical term. Next, you want to raise each side to the appropriate power. So since this is a square root, we're going to square both sides. So on the left, I have the square root of x minus 3. And on the right, the 5 squared. You've seen the square root squared many times. You're left just with the x minus 3. And over here you have 25, which leaves you with x equals 28. Now remember, we want to check each of our answers to make sure that they do in fact work. This is very quick. You want to plug it into your original expression, so that's up here at the top. My stylus isn't cooperating, so be patient. All right, we're going to plug it into the original, so you have 2 times the square root of 28 minus 3 minus 10, and we want to know if that equals 0. So 28 minus 3 is 25. Square root of 25 is 5, so 2 times 5 is 10, and 10 minus 10 does equal 0. So this checks out, and we can be certain that x equals 28 is in fact our solution. So it's very quick to check your answers when you're finished. Okay, next equation. Take a minute and copy it down. The square root term is already isolated, so we don't have to do any work to move anything around, so we're ready to square each side. Now when we square the x minus 4, you need parentheses. And then you're going to square the square root of 2x. Now over here, be careful, this is what you don't want to do. You don't want to write x minus 4 squared, so you have no parentheses. This is really x minus 16, this is not correct. The other thing you don't want to do is, even if you use the parentheses, so x minus 4, the quantity squared, if you tell me that this is x squared minus 16, that's going to be wrong as well. So don't do that. Remember to FOIL. I'm just going to adjust the screen a little bit here, though, to see if my stylus is going to work better. So you guys go ahead and FOIL x minus 4, the quantity squared. You should get x squared minus 8x plus 16. X squared minus 8x plus 16. And over here, when you square the square root of 2x, you just get plain old 2x. Now you're ready to solve. So you're going to move all of your terms to the left. X squared minus 10x plus 16 equals 0. This is quadratic, so you want to think about factoring. This is easily factored into x minus 8x minus 2. Which leaves us with x equals 8 and x equals 2 as possible solutions. Now let me erase this over here, because we have to check both answers this time. Let's start with x equals 2. Again, you're plugging it into this line up here. 2 minus 4. Does that equal the square root of 2 times 2? So 2 minus 4 is negative 2. And the square root of 4 is positive 2, so this is a false statement. That means that your x equals 2 solution you have to reject. Then you check x equals 8. Plug it into the original. So what you want to know is 8 minus 4, does it equal the square root of 2 times 8? So 8 minus 4 is 4. Square root of 16 is 4. So this is true. X equals 8 is your only answer. So in this case, we can see that we did in fact have one extraneous root. Right, here's your third example. This one's not difficult. I just wanted you to have an example where our radical was not a square root. This time we have a cube root. The steps still apply. You need to isolate the cube root, so you're going to subtract 6. And this time you're going to raise each side to the third power. Cube root of x cubed is just x. And then you have 6 cubed, which is 216. Do a quick check. The cube root of 216 plus 6, does that equal 12? Yes, 6 plus 6 equals 12. So you're good. X equals 216 is your answer. Okay, if you're behind, maybe somebody wants to stop the video, make sure everybody is all caught up. You can go back through the pages if you need to. Otherwise, let's move on. Same idea. This time we have a fourth root. Nothing is different. Isolate the fourth root. You have to bring the 5 to the right. Watch your signs here. So by the time you get the fourth root isolated, you have the fourth root of x equals positive 5. You're going to raise everything to the fourth power. The fourth root of x to the fourth, of course, is just x, and 5 to the fourth is 625. And to quickly check, 5 times, sorry, 5 minus the fourth root of 625 leaves us with 5 minus 5, and of course that's 0. So you can see that lots of times this work for extraneous roots tells you that you don't have anything that doesn't work. You have only correct solutions here, and the check is very quick. Don't skip it, because that's going to be the one problem where you're supposed to be rejecting an answer. Okay, so let's move on to the types of equations where you will have two radicals. The only thing that's different here is that you want to make sure that you have one radical on each side. So you may have to move one of them across the equal to sign. This might be a good opportunity to stop the video, make sure everybody gets these notes down into their copybook, and the first example ready to go. Okay, so look, we have two square roots, both are on the left, so you want to put one on one side, one on the other. The easiest term to move over is the negative 2 root x, so move it right. Now you're right back where you started, so you want to raise each side to the appropriate power. This would be to square each side. Now you have to be really careful with your parentheses with these problems, because even in this one, there's an extra number to worry about. On the right here, you want to make sure this 2 root x, the whole thing goes in parentheses, because that's going to indicate to you what you actually have to square. The square root of 3x plus 2 squared is just 3x plus 2. Now when you're here on the right, make sure, okay, if you need to, put an asterisk next to it to remember. You're going to square the 2, that gives you a 4, and the square root of x squared is just your x. And then the rest is straightforward. So we're going to move the 3x to the right, and you get that x equals 2. Oops. X equals 2. And of course you want to check. There's a little bit more to the check here to keep track of some more things. We have the square root of 3 times 2, which is 6, plus 2, minus 2 times the square root of 2. Does that equal 0? That's what we're trying to figure out. The square root of 8 minus 2 root 2 equals 0. And 8, when you simplify it, is 2 root 2 minus 2 root 2 then yes, that equals 0. So you can circle x equals 2 as your answer because you have shown that it works. Alright, let's go through a couple of examples along these lines. Here's your next one. The square root of 4x plus 28 minus 3 root 2x equals 0. So first step, put one radical on the left, one radical on the right. I think moving the negative 3 the square root of 2x to the right is the quickest thing to do. Once you've done that, you're going to square each side. Again, be really careful. It's easy on the left here. That's just going to leave you with 4x plus 28, but on the right, you have to worry about squaring both terms. Three squared is 9. The square root of 2x squared is just 2x. And that's going to leave you with an 18x over here on the right. So again, girls, be really careful. If you think you have to make a note in your notes, do. Lots of times, lots of places where you can go wrong here. If you don't use the parentheses on this step, you're not going to get the 9. If you don't get the 9, you're not going to get the 18, and then the whole thing is going to be off. Alright, the rest is easy. 28 equals 14x, and x equals 2. Check. Back here at your original, this is where you're plugging your value of 2 in. We have the square root of 4 times 2, that's 8, plus 28, minus 3 times the square root of 2 times 2, or 4, and you want to know if that equals 0. 28 plus 8 is 36, so we have the square root of 36, minus 3 times 2. Square root of 36 is 6, 6 minus 6 is definitely 0. So there you go, it checks out, and x equals 2 is your answer. Alright, again, don't hesitate to stop the video here, girls. I've moved pretty quickly through this problem. I want to make sure that you have everything you need in your notes. Maybe 2 more examples. This is an example of a cube root, so very straightforward, but again, so you have something in your notes that's not just a square root. We have one on the left and one on the right, so you're ready to go. You're going to cube each side. The cube of a cube root, you're just left with what's under, the radical. X plus 4 equals 2x minus 5. Negative x equals negative 9, x equals 9. Now when you go to check this, girls, you end up with a radical. You don't need the decimal. You're just trying to make sure that the left side equals the right, because our first line is set up that way. Okay, so you're going to plug 9 in. You're going to have the cube root of 9 plus 4. That's the cube root of 13. And over here you have the cube root of 2 times 9, which is 18 minus 5. So you have shown that the cube root of 13 equals the cube root of 13. So you don't have to know exactly what that is. It's just that the left equals the right and x equals 9. Alright, let's switch the page if you're ready. And here's our last example. Notice I've already marked it as something that you have to be careful. We have two radicals. Let's put one on the right side. I'm going to move the negative square root of x minus 1 over. It's a square root, so we're going to square each side. The right side is easy. You just have x minus 1. Be careful with the squaring of x, 6 root x. 6 squared is 36. Square root of x squared is just x. So far it looks pretty easy, right? 35x equals negative 1. And x equals negative 1 over 35. Alright, let's see what happens when you go to check. You're going to plug negative 1 over 35 into this first line right here. So 6 times the square root of negative 1 over 35, and you can see the problem right away. You don't even have to finish. I'm just going to fill it in here. Okay, this is a negative number under an even root. So we're going to reject this solution, because you can't take the square root of a negative number. And you're going to conclude that there is no solution to this problem. Let's try that again. So here's another example where checking for your extraneous roots led you to no solution because you had that square root of a negative number. So you definitely don't want to skip the step of checking. Alright, girls, so you have a number of examples, some with one radical, some with two radicals, some where you had no solution, a couple where you rejected one of two possible solutions, and several where everything stayed a solution. Here is your homework. It's already posted on Edline. There's time at the end of class, and the moderator allows you to work together. You can on these problems, otherwise get started independently. I will go through them tomorrow, so hopefully this went well in class. You were able to get through the video without too much complication because it was the big group. And I'll see you guys tomorrow.